So let us begin today's session. In this session, we are going to see the problems based on economic load dispatch, and this topic is very short and one of the important topic for our GATE exam. Every time we can see that always 2 or 3 marks question being asked from this economic load dispatch chapter. So let us first we are having short recap for on this economic load dispatch. So can
Sir,
anyone?
I have zero knowledge on this topic, sir. So
Okay.
please start from the beginning. I request you, sir, for that.
Yes, just it will take 2 minutes. Don't worry. And
Okay, sir.
only means just be patient for means 5 minutes. More than not more than five
Okay,
minutes.
sir.
So what? As we know that economic load dispatch. What do you mean by economic load dispatch? Economic load dispatch means that you are setting up the power plants at certain amount of power generation by minimizing the cost function and and maintaining the constants like power constant, that is equality constants. So this is economic load dispatch. And if we see the for thermal power plant, the cost curve can be approximated in the form of this expression, and this ci the unit of ci is rupees per hour.
Sir, if I mail you, sir, then will you give this PDF to me, sir?
Yes, today I will share the link at the end of class. And are you able to access the last recorded video, means last session?
No, sir. It's not there, I think.
I think that will take time on the to be uploaded on the portal. And meanwhile, what you can do that I will share you the link for YouTube. From there you can access till that time.
The
And
recording video, oh, you are talking about the recording video, sir.
yes, sir, yes, I am recording this all videos.
No,
So
sir, I am saying about this PPTs or PDF, sir.
yes, I will
PDF.
also share that. Don't
Okay,
worry.
sir.
So if you take the derivative of this fuel cost, then you will find this incremental fuel cost, and that is expressed in this form. And so that the unit for this incremental fuel cost will be rupees per megawatt hour. And there are two cases for this economic dispatch problems. If we consider line losses, that is the first case, and in another case that in neglected the line losses. So in this first we will see that economic dispatch while neglecting the line losses. Neglecting the line losses means whatever the power is generating, that is equivalent to the load power. So PGI is equivalent to summation of PLI. And the condition for this economic dispatch while neglecting the line losses, that incremental cost for all the generators should be equal. So that is this is very important. IC1 is equal to IC2 and so on, whatever the amount of generator present in the plant. And I have written down this expression: the optimal loading of generator occurs corresponding to the equal incremental cost point of all the generators. We will see the problems based on this. And the next case is that economic dispatch considering the line losses. And in this case, whatever the generated power, that will equal to the load power. PLI is the total load power summation of PLI total load power plus P loss, that is the losses occurs in the transmission line. And optimal loading, for in this case the condition is for this optimal loading is that one another factor came in this incremental cost, that is penalty factor. And penalty factor multiplied with this incremental cost should be equal for all the generators for having the optimal loading, that is economic dispatch. And we generally we have in case this increment penalty factor should be lesser, should be lesser for the good power plant. So now we will solve the problems based on this two expression that is first expression is that uh, uh, first expression is for this case in which line losses are neglected, and the second expression is that in which the penalty factor came. So the first question we are having this, so you can try yourself, and after 1 or 2 minutes I will solve this problem. Yes, this problem is from gate 2022. It is one of economic load dispatch is one of the simplest chapter, is one of the easy chapter, and the most scoring for the gate exam. And whoever is getting the answer, type your answer in the chat box. So in this question, it is given that the fuel cost function in rupees hour for two 600 megawatt thermal power plants are given by. So the fuel cost is given for plant 1 and plant 2, and where P1 and P2 are power generated by plant 1 and plant 2 respectively in megawatt, and A is constant. So A is the variable here, means A you need to find out. The incremental cost of power lambda is 8 rupees per megawatt hour. And here this incremental cost is also given 8 rupees per megawatt hour. The two thermal power plants together meet a total power demand of 550 megawatt. So total load is 550 megawatt. The optimal generation of plant 1 and plant 2 in megawatt respectively are. So nothing is given about line losses, so just assume that we have to neglect the line losses. So we know that for optimal operation, while neglecting the line losses, what is the condition that need to be satisfied? Incremental cost should be equal. That is IC1 is equal to IC2. And in this question, it is given by 8 rupees per megawatt hour.
Sir, incremental cost one means for the generator one,
Yeah,
and
yeah. And incremental cost, IC2 means incremental cost for generator 2.
mm,
So uh, we can find out first the PG1. You can also draw the diagram.
sir, incremental cost means if you increase the load, then the cost will be increased. increases, cost increases.
Incremental cost means that is curve, like if you see that lower the incremental cost, that higher will be the sharing in the plant. But means if you draw the incremental cost curve, but here this incremental cost for both the system will come different.
Okay, sir.
PL is, what is the PL is given as 550 megawatt. So this is generator 1, this is generator 2, and you need to find this P1 and this P2. So first expression from this, no, first we will find, we are having given this C1. C1 is given as 350, 350 plus 6P1 plus 0.004 P1 square. So what is the incremental cost IC1? You can write DC1 divided by DP1. So that will be 350 will be 0, and 6P1 6 plus 0.008 P1, and this is equivalent to 8 rupees. So from here you can find this P1 value. So P1 will become out as 250 megawatt. And since this all the generation will come, will generation will equal to the load power, so P1 plus P2 equal to 550 megawatt. From here you can find this P2. P2 will be 3 250 minus 550 minus 250, that will be 300 megawatt.
Sir, or we can directly differentiate that C2, uh, C2 that.
Yeah, you can that do that one also, but in that case again there are two variables a and p2, so you again need to find this p2, correct?
Yes, sir.
Because c2 is what, c2 is 450 plus a p2 plus 0.003 p2 square. So if you find ic2, then it will be a plus 0.006 p2. So if you either equate this to 8 also, then two variables are there, a and p2. You need to again go through this only. So there is no
Mm.
need to calculate the value of a.
Yes, sir.
So for this problem, the correct option is B. Correct option is B, 250 and 300 megawatt. Is there any doubt till here? Whoever is getting answer, you can type your answer in chat box. So let us see the next problem. Next problem is the recent one, that is from GATE 2023, and this is quite a bit lengthy. So you can try yourself, but I will solve this quickly. So this is second number problem, and this, so in this problem it is given that the expression of fuel cost of two thermal generating units as a function of the respective power generation Pg1, Pg and Pg2 are given as. So, so the notations can be different here in irrespective of C1, it is denoted by F1. So F1 Pg1 is 0.1 a Pg1 square plus 40 Pg1 and so on. And F2 is the fuel cost is given for the second generation unit, and these are the constants, power constants, power constants for each generating unit. What happens that if you find this power values uh, for this economic dispatch, but if you are getting this power more than this the maximum value, then you have to assume the maximum one limit only. So just be careful if you solve that type of problem in which that you are getting economic dispatch at more power whatever they mentioned, that is whatever mentioned the maximum value. So
Sir, does it in this question, does we have to consider, or do we have to consider losses also, or not?
no, means for losses they will mention loss expression also. So means nothing is mentioned about loss, then you don't need to take care, because penalty factor you need to find this. You cannot find the penalty factor without using the loss expression. Means like this cost function is given, they will also mention the loss expression, power loss expression. So we will solve that problem also. Generally, in the GATE exam, they will more there have been more asked about this without considering the loss.
Okay, sir.
But that you also means for 1 marks, and they will also ask an expression in the formula type. So that you also keep in mind. For a given value of a optimal dispatch requires a total load of 290 megawatt. So total load is 290 megawatt to be shared as PG1 120 megawatt and PG2 115 megawatt. So for a certain value of A, they have found out the economic load dispatch, and this PG1 come out as 175 megawatt and PG2 is comes out as 115 megawatt. With the load remaining unchanged, the value of A is increased by 10%. And in the second case, this is the first case, and now we are moving to second case. So in the second case, load remains same, and the value of A is increased by 10%. The optimal dispatch is carried out, and the change in PG1 and total cost of generation F in rupees per hour will be as follows. So there are four options. You need to calculate this PG1 and F for the second case. Means when the value of A is increased by 10%, and for that you need to find the value of A while given the optimal dispatch conditions and the powers. This type of lengthy problem is always asked in 2 marks question, but if you having patience in GATE exam and you solve just carefully, then you will there is no you will you will easily get the answer. So I have solved this problem. So what are the given things? The fuel cost of first thermal generating unit is given, and the fuel cost of second thermal generating unit is also given, and the other things are given as the for optimal operation of total load 290 megawatt. The load shared by generator G1 G2 are given by 175 megawatt and 115 megawatt for G1 and G2 respectively. So you can draw this figure, and from this from this condition of optimal loading, we will find the value of A because other things are given. So if we are having neglected the line losses, so we know that optimal loading of generators occur corresponding to the equal incremental cost point of all the generators. That is IC1 is equal to IC2, where IC incremental cost is the derivative of the fuel cost with respect to power being generated by that generator. So moving forward, so if we find this incremental cost of first generator, then it will come out as 0.2 APG1 plus 40, and for the second generator it will come out as 0.4 PG2 plus 30, and for optimal dispatch we know that IC1 is equal to IC2 corresponding to the generation with, with respect to that generator. So we put all these values, we will get the value of A from the first condition, from the first case. So A value will come out as 1.0857, and so we will also find this total fuel cost, because in the options it has been asked that you have to compare the power generated by generator 1 and the fuel cost. So total fuel cost will be in the first case will be F1 plus F2, and correspondingly you put all the values along with the value of A. So we will get the value of F as 16,465 rupees per hour. So this value we will need at the end. And so now we are going through the second case. In that case, A is increased by 10% and the load remains unchanged.
But sir, wait, sir, what you did just now, total cost. So can you explain this part again?
Total let's first see the problem. In this problem, it has asked that total cost of generation.
So I've understood till we found the value of A.
Okay, so total cost of generation, how will you find this?
F1 plus F2. Okay.
F1 plus F2.
We simply just put the value of A and PG1 and PG2 and then we added it, right, sir?
Yes,
Okay, sir,
nothing
then
is
it's simple.
nothing more is in that.
Okay, sir, got it.
So this you just calculate. This is just it is little bit lengthy, and whoever knows that for while neglecting the losses, you just need to equate the incremental cost. You will get the answer, and other
So then
things are
again we have to put
calculation.
then
Hmm?
sir again we have to put the incremented value of A and again we have to differentiate and equate
Uh,
and I
no,
think
no. Why you need to again differentiate? Because A1 is A1 remains as it is. So here in the place of A, earlier it is 1.0857, right? So in the place of A, you will put A1. So A1 will be 1.1314. The
hmm,
first expression will be load remains unchanged. So Pg1 plus Pg2 is equal to 290 megawatt. And the other
okay
expression
sir.
for optimal dispatch, IC1 is equal to IC2. And in the
Hmm.
place of A1, in the place of A,
One
you
point.
put A1. So
Okay sir.
this will 1.1314. So you will get PG1 and
Yes sir, got it.
PG2 from the two expressions.
Hmm.
So earlier PG1 was I think what is PG1 was 170 megawatt. Now
Mm-hmm.
now in the second case it has decreased 169. So we can say that PG1 has decreased. And now similarly the fuel cost can be calculated with respect to the new power generated by the generators. So PG1, you calculate F1 with respect to PG1 169, and F2 with respect to Pg2 is equal to 120 megawatt. So we will get F value as 16,769.73 rupees per hour. So earlier we got F value as 16,465. So this value has increased. F value has increased and PG value has decreased.
It's a simple mathematical question, sir.
Yes.
It's not
So
difficult.
what value will be, what correct answer will be? A is the correct answer.
PG1 will decrease and F will increase.
I have picked two questions from both cases, means while considering the line losses and while not considering the, while neglecting the line losses.
So in case of losses, we just have to, I think, add. We have to, I think, use PG1 is equal to PL plus loss, and we can, I think, find that also.
In case of losses, if first the condition is different. For optimal dispatch, the penalty factor will come, and then
Okay.
yes, the power generation will be equal to the demand power plus losses in the line.
Mm.
So let us see the problems based on that also. So
Okay, sir.
this is question number 3, and just carefully read this and solve this problem. And I am giving you 2 minute time.
So can you share the formula for penalty, sir? Again, once again, penalty formula.
Penalty is 1 divided by 1 minus dp loss, derivative of p loss with respect to pg. This one.
Okay, sir. What is delta? Delta optimal loading for generator.
Delta I just expressed because all values are equal for the every generators. It is not delta, lambda. Sorry, lambda I just expressed because L1 DC1 dPg1 is equal to L2 DC2 dPg2.
It is same for all.
For while considering the line losses.
Okay.
If you write it in general form, then you will not have privilege to equate. So that's why I use the other expression is equal to lambda. Just simply you can say. So see this third problem. So as I mentioned, if this P loss comes, then you have to consider the line losses. So here P loss is given. So the third question is the figure shows a two generator system supplying a load of 40 megawatt connected at bus 2. So this is the total demand power 40 megawatt. The fuel cost of generators G1 and G2 are given as 10,000 rupees per megawatt hour and 12,500 rupees per megawatt hour. And this question is quite long back has been asked. It is asked in GATE 2012. But see the it in this question it is mentioned fuel cost. But why, if you look on the unit, then it is not the fuel cost, it is incremental cost, right? And here also, because the unit for fuel cost is rupees per hour, and if you differentiate with fuel cost with respect to power, then you will get rupees per megawatt hour. And the losses in the line is given in the per unit expression, where the loss coefficient is specified in per unit to be 100 MVA base. So we will need this base value at the end, while because we get PG1 and PG2 in the per unit. So calculate based on this per unit value only. Then the most economic power generation schedule in megawatt is. All of you note down the important points, and I am moving to the next slide. So this question is from economic dispatch considering line losses. So we know that what is the expression del I del Pg1 is equal to L2 dC2 dPg2, or you can say that L1 into IC1 is equal to L2 into IC2. First we will find the L1 and L2 for both the generators. So L1 will be 1 divided by 1 minus dP loss dPg1. So P loss is given. P loss is what? P loss is 0.5 Pg1 square per unit. So we will also do the in per unit only. It is given. So L1 will be what L1 value come out as. If it is differentiate with respect to Pg1, it will come out as Pg1 only. So this is L1. And similarly we will find L2. So L2 will be 1 divided by 1 minus Pg. If you differentiate Pg1 with respect to Pg2, it will be 0. So L2 will be 1 value. Now simply you need to just put all this in the first expression,
Sir, why PG1 is 0, sir?
because uh, here if you put differentiate 0.5 into Pg1 square with respect to dPg2, then in the differentiation side no value is Pg2, so it will be 0.
Okay, sir.
Understood?
Got it. Hmm.
So and IC1 and IC2 is also given 10,000, and IC2 is also given 12,500. So put all this value in this expression. So putting all this value, then L1 is 1 divided by 1 minus Pg1, IC1 is 10,000. Here 100 MVA base. So just write it in a per unit value, then it will be 100. So 100, just you need to put 100 here, and then here 1 into 125. So from this From this, you will get Pg1 value as 0.2 per unit.
So we have to write that IC1 and IC2 according to the base, the given base, MBA base
So MVA base is given as 100 MVA.
per
So
unit. We have written in per unit.
yeah, so we have calculated in per unit. So the correct Pg1 actual will be 0.2 into MVA base. So 100, it will be 20 megawatt. And Pg1 plus Pg2 is, so in this case we have considered the losses. So we will get whatever the expression for power equality constant. So demand power in this question. So here, if you write the power express equality constant equating the power, then demand power will be equal to Pg1 plus Pg2 plus loss power. So we will write this only. Pg, sorry. First, but here you also need to calculate this P loss also. So P loss we will calculate. P loss is 0.5 into Pg1. Pg1 is 20, so it will be 20 into 5 into 0.5
Which
in,
expression? Which
sorry, it will be in per unit. So here it will be
expression,
0.04.
sir?
Yes,
Which
0.02. So 2 megawatt here will come. Yes,
which expression, sir? You are. Okay, for this expression, P loss is equal to, okay, sir, 0.5 Pg1 square. Okay, in
hmm.
that way. Okay,
Yeah.
sir, got it.
So Pg1 per unit will be 0.04. So this is per unit value, and you multiply with 100, then it will be 2 megawatt. Now you need to simply equate the power. So we know that demand power will be, sorry, demand power will be Pg1 plus Pg2 minus P loss. Here I have written wrong. It will be minus, because whatever power generated, it will go to the load or loss power. So put all these values. Demand power is 40, Pg1 we are getting 20, and Pg2 we need to find, and P loss is 2 megawatt. So Pg2 will be
22.
22 megawatt. So therefore the correct answer will be, what will be the correct answer? Which will be the correct option? A1
P
is the,
A, yes, sir. Yeah.
A is the correct option. So this we have seen problems based on the economic load dispatch while considering the line losses and while neglecting the line losses. Now we will see the problems based on the governor speed regulation, that is droop equation. So we will solve problems based on that. That is problem number 4, and this question has been asked in GATE 2017. I just request all of you that solve all the previous year good question At least you will familiar with the problems. And if you see this problem has been asked in GIT on 17 and another question again asked in GIT for 2022. Both are similar type. So they are not manipulating much means in the questions. They are just playing with data and sometimes they ask some more new type questions. But if you are having practice the get questions, then you will crack the question in the exam also. So, and all of you try yourself also. I'm giving you 2 minutes time. So in this problem, it is given that two generating units rated 300 megawatt and 400 megawatt have governor speed regulation of 6% and 4% respectively from no load to full load. Both the generating units are operating in parallel to share a load of 600 megawatt. Assume free governor action. The load shared by the larger unit is dash dash megawatt. So the rated value are 300 megawatt and 400 megawatt, and always whatever the rated value be considered it as maximum value for that generation. Means it can provide maximum power of 300 megawatt and 400 megawatt respectively. So the rated value always is the maximum limit. So that is also you need to keep in mind. So both generating units are running in parallel. So if you make it in figure, then PG1 rated is given as 300 megawatt and 6% is the governor speed regulation. And second figure is that second generation unit is that rated value is given as PG2 rated is 400 megawatt and this value is 4% governor speed regulation by which we can change the frequency by which the frequency is getting changed. So these are running in parallel and we are having total demand of 600 megawatt. So you need to find the PG1 and PG2 load share by the larger unit. Larger unit is the 400 megawatt. So PG1 and PG2. Larger unit means in this question it is asked about only PG2. Once you can if you find one value, then you can get easily by subtracting from 600 megawatt. Is there any WhatsApp group for discussion gate power system? So you can make among yourself. So students can make. So we have less time, so just I am solving this, and you can also solve parallelly with me. So for this type of problem, first we will make FP curve. We will put the frequency on the y-axis and power on the x-axis. If you see the droop a speed regulation, means for generator 1 it is 6%, so the steep will be more. And for generator 2 it is 4%, so it
So
will
this question is from synchronous generator, right, sir?
what.
This question is from synchronous generator, I think, from machine.
No, no, this type of question comes in power system also. Means it is concepts are concepts come in both questions, but you can
The language is different a little bit.
this speed regulation and this voltage control, means how we will know that how frequency is changed while dispatching the active power, how voltage is getting changed while dispatching the reactive power. So this concepts is power system also.
So just language has been changed, sir. I think little
Language.
bit. The language.
But if for power system engineer also they should have knowledge about how the FP curve works and how the QV curve, how the voltage and reactive power curve works.
Yes, sir.
So considering the no load frequency is 50 Hertz, and after getting the droop this frequency will get changed. So for this one is for first generator and this one is for second generator 4%. So this is F1 full load and F2 full load. And now this curve is while sharing the power, of 600 megawatt. So this one is PG2 and this is PG1, and PG2 max will be 400 megawatt, and this PG1 max, that is rated value, it will come as 300 megawatt.
So speed regulation is 4% for this. So steep curve will be for
4% for
6%.
the second generator means rated value is 400 megawatt.
Hmm.
So 4% means that if you are going from no load to full load, then the
It will take more time.
change in frequency will be uh, 4% means if you calculate the for the second generator like F2 full load, then you will use this speed regulation. So F2 full load will be 50 minus 4% of 50 hertz. 50 minus 2 is equal to 48 hertz. So this value F2 FL is 48 hertz. Similarly, we can find F1 FL frequency at full load for generator 1, that will be 50 minus 6% of 50. Then this value will be 50 minus 3, so 47 hertz.
The difference is more.
Means if this coefficient, if say, a speed regulation is more, then this frequency change will be also more. So this is the case. So if we write to down the slope for this generator one, then what? How can the slope will be the change in y with respect to change in x. So change in y will be by changing is 3. So 3 and change in x will be minus 300. So slope will be minus 1 by 100. And for this generator one, slope will be change in frequency will be 2 and change in power will be minus 400. Similar, so we can write the general expression of line by is equal to mx plus c. So we can for frequency for generator 1 by is equal to mx plus c, you simply put pg1 plus 50, and for f2 minus 200 divided 4 pg2 plus 50. This is the general expression for general expression of frequency for generating unit 1, and this is general expression of frequency for generating unit 2. So this expression is comes from simple mathematics by is equal to mx plus c. Slope, this is slope and this is intercept.
The slope, sir, the slope of PG1 will be positive, sir.
Both slopes are negative because it is more than 90 degree. So that's why I have written down it in negative. And you can simply slope, how you write slope? Y is equal, m is equal to y2 minus y1 divided by x2 minus x1. So by 2 you are changing, by 2 is
For
take it
PG1, sir, sir, for PG1,
y2 is 50 and x2 is 0, and by 1 by 1 is 47 and x1 is 300. So that's why it is minus 3 divided by 300.
sir, the origin is 0, sir. So PG1 will be minus 300, sir. If you take
Yeah,
the
so that minus 300, so that's why negative is coming. That's why
so
I'm
minus and minus 300, sir, is plus 300. I'm saying in that way, sir.
oh no. Actually we have made both in the same graph, that's why you are confusing. Yes, you are correct. But correct way is that you have to make both the curve in the same side, but that will be more not clearly you can find out. That is not much clear. That's why made in both means like side by side. Understood?
Hmm.
Yes, you are getting confused because this is negative. So not this is not like that. This is general means like we used to make.
Okay, sir. For simplicity, sir, to solve the
Mm,
problem.
Hello, sir.
yes.
I have doubt in calculating the frequency at full load. Why are we multiplying? Why are we doing 50 minus? In the, for example, in the first case, 50 minus in 6 by 100 into 50. Why are we multiplying by the into 50?
Because in the problem, if you see the governor speed regulation of 604% respectively for no load to full load. It is
Okay.
given that
Ah,
if you are going from no load to full load, then there is a droop in frequency of 6%.
okay.
The governor speed regulation, you can also say droop, means there is droop in frequency of 6%. So that's why we are subtracting 50, we are subtracting the frequency at no load with respect to this droop percentage.
Okay. So we are
Sir,
multiplying.
no load minus full load by no load is equal to percentage. In that way, sir, I
Yeah,
think. Mm.
yeah.
Okay. Okay.
And that this expression is also, I think many of you know that.
So when
Means
changing is with respect to the no load, then we have to take the base or the denominator as no load. If changes with respect to full load, I think we have to take the denominator as full load. But here from no load
we
we are
we
changing.
also
So
know
no.
that this expression. So from there also we will get, right.
Oh,
Yes, sir,
okay,
this
sir.
one.
So this expression you can also use. So till here, is there any doubt? So now we need to just put this F1 is equal to F2. Oh God. So since generating units are operating in parallel, operating in parallel, so F1 is equal to F2 because frequency will be same for both the generators. So from the last one means this one, you can take 1 and 2, you will put F1 and F2, 50 minus 300, 3 divided by 300 Pg1 is equal to 50 minus 2 divided by 400 Pg2. So it will be 1 divided by Pg1, 1 divided by 200 Pg2. So Pg2 will be 2 into Pg1. So this is the first expression, and also we have given that Pg1 plus Pg2 is equal to PL, total load. Total load is 600 megawatt. Set. So therefore, put both using both expression, we get 3 Pg1 is equal to 600. So Pg1 value will be 200 megawatt and Pg2 value will be 400 megawatt. So in this problem, it is asked that the load set by the larger unit. Larger unit is Pg2. So 400 megawatt will be the answer. Answer is 400 megawatt. No, Venkatesh, this is not from economic load dispatch, but generally we will consider in this chapter only because we cannot include this type of problem in another section. In the last tutorial, we have solved the basic problems, inductance calculation, and many problems are left for that part. We will solve in the we will try to solve in the end, and I will also try to just make a short notes on the expressions that will be useful for the GATE exam. And for this chapter, only two expressions generally be required, and especially for GATE exam. Another exam, if you are having the state level other exam, then you need to more focus on theory also.
Sir, will you stretch these videos till till the gate exam?
Yeah, this will run till the GATE exam.
Okay.
I hope till this point, means everything is clear. If there is no doubt, we are going to see the next problem. This problem has been asked in GATE 2022. So as the previous problem we have solved, this is the the similar type, nothing is changed. So you can see that in the gate exam also they don't change much. Means this problem we have solved, that is asked in gate 2017, and the similar type problem is asked in gate 2022. Nothing is changed, just data is changed. So I
Do so
just,
do, so do we have to check the 5 years like 5 years back question from the 5 years back? Like we have to check 2019 question
yeah.
because 5 years we are changing.
After, because as the number of problems increased, means whatever the problem solving, more number of problems you have solved before the gate exam, that will beneficial for the for your exam. I don't know, miss, in our time, whatever the question bank we used to solve, in that problem they just include the problems from means I gave gate exam in 2019. So at that time they are including the question from 1990 also. So we used to solve all the problems, whatever the problem related to your means syllabus, you have to solve all the problems of gate exam. Means, so I am just writing down the answer for this problem, and I will include this PDF by solving this problem also. But right now we don't have time, so just I want to you solve yourself, and this is just like homework. Whoever understood the previous problem, definitely they will solve this problem also. Nothing is changed, just data is different. I hope you are able to solve this problem. And in the final PDF, I will just share the solution also. So for the last session, I am just putting the link, so you can go through this YouTube link and get the recorded video. And I have also shared this PDF of the slides in the description box, so you can get that also. And today I will upload this today's recording video also. Thank you everyone.
Thank you,
And
sir.
if you have doubt, you can ask. Hello Antanu,
Yes, sir.
you have any doubt?
No, sir, I don't.
Thank you everyone. And if you have any query, you can mail me.
Sure, sir.
Yeah. Thank you everyone. Bye bye.